Okay, so I'm back, and of course here's your power formula that tells you that you're going to multiply that power in front with whatever coefficient's already there, and notice then I've decreased the power by 1. Sometimes we refer to it as dy dx, or sometimes we refer to it as f prime of x. Okay, so if we do these, you should be able to do them super fast in your head. So I would bring the power down in front, multiply by the coefficient, which is 1, and then decrease that power by 1, so now I have 4x cubed. And for the next one, I have to do each term separately, like I was up above. And so on the first one, if I bring the power down, I'll have 8, because I'll have 2 times the 4 in front. And then I'll decrease the power by 1, so it'll be 8 to the first. And then remember that this is really x to the 0, and so if I multiply 0 times 4, that gives me 0, so I just end up with 8x. And then on this last one, remember I can rewrite this. This is the same thing as 2x to the negative 3, since the 3 is in the bottom. And so again, I'll multiply power by coefficient, so I get negative 6, and then I'll decrease the power by 1. And so if I decrease the power by 1, I'll get x to the negative 4. And of course, I could write that as negative 6 over x to the 4th. Okay, on the next one, again, I want to find the slope, but this time I'm finding it at a particular point. So the first thing I'll do is I'll find the slope, so I need to take my derivative. And again, I'm using that same process of powering down. So the 2 times 3 gives me 6 in the front, and then the new power will be x to the first, because I'm going down by 1. Again, this has an x to the 0 at the end of it, so if I multiply it by 0 times 1, I'll get 0. So my slope is nothing more than 6x, and then if I want to find the specific slope at x equals 5, then I'll simply plug in the 5, and so the slope when x is 5 is nothing more than 6 times 5, which is 30. That's my specific slope at x equals 5. Keep in mind that this was the general slope for any point on my curve. Okay, and then these are all some quick rules that will make more sense as we use them. So if I have a constant, which I had in the problems up above, the constant just gets multiplied out in front. If I'm adding or subtracting terms, which is what we were doing on some of the problems again up above, if I'm adding terms, then I'll take the derivatives and add them. If I'm subtracting terms, then I'll take the derivatives and keep the subtraction. So that's not really anything new. Now, the one that is new, however, is product rule. Notice on the product rule, I'm taking the first term and then multiplying by derivative of the second, plus then I'm switching and I'm taking the second term and multiplying by the derivative of the first. So it's first times derivative of the second plus second times derivative of the first. We're going to see some products. And then if I'm taking derivative of a constant, it's nothing more than 0. We've seen that up above. Following along with that, if I'm taking the derivative of just x, remember that's x to the first, so I'd be doing 1 times 1, which would give me 1 in front, and then x to the 0, but x to the 0 is just 1, so derivative of just x is 1. Now, I didn't skip this quotient rule. I'm going to go back to it here. So now, the quotient, this is what you have to learn to say. Low, high. Lucky for you, you go to Los Osos High School. So low, high. So we say that it's low, and then derivative of the high minus the high, and then derivative of the low, all over low squared. So low, high helps me remember that I'm doing